indefinite integrals? Well, in our previous lectures, we have completely understood the significance of indefinite integration of a function, right? We understood what that stands for, we understood what it represents, all those things we have understood. And one thing which is of primary importance is what do we mean by integrating a function in an indefinite manner. You all know that if you have a function, say fx, another function phi of x is called a primitive or antiderivative or integral of fx, provided differentiation of phi x with respect to x is fx, right? When d by dx of phi x is fx, we say phi x is one antiderivative, one primitive or one integral of fx, right? And we all know that if phi x is that function of x whose differentiation is coming out to be f of x, obviously adding or subtracting a constant from phi x is not going to change this fact even then. Even then, that means when I add c to phi x, where c is any constant, it can be negative or positive, when I add c to my function phi of x, even then the differentiation of phi x plus c is my function fx, right? That means the very first function which is an antiderivative of fx is supposed to be found, isn't it? The moment you find that function of x, that is phi x, which is that one function of x which is a primitive of f, the moment that is found, rest every other primitive of f will be that function plus c, right? If phi x is one primitive of f, this implies rest all the other primitives are just phi x plus c. They are all other primitives or antiderivatives of the same function f. That means if you collect all the primitives of f, how do they look like? Phi x plus 1, phi x plus half, phi x minus 2, phi x minus 3 by 2, phi x plus 3.5, everything is in the form of phi x plus c, where c is any arbitrary constant, right? That means it is this antiderivative which is utmost important. The moment this antiderivative is found, I am not worried about finding any other antiderivative of f. Second thing, any two antiderivatives of f, say phi x plus c1 is one antiderivative, phi x plus c2 is another antiderivative. As I told you, in the entire family of antiderivatives of f, any two antiderivatives are going to look like phi x plus c1 and phi x plus c2, where phi x is that one original function of x which is antiderivative of f. Any two antiderivatives of f are only going to differ by a constant, no function of x. They are only going to differ by a constant, right? So over here, if I try to tell you, it is only this antiderivative which is a function of x, right? Apart from that, every other antiderivative is this antiderivative plus constant. Cool? Once we have understood this fact about antiderivatives of f, we know that indefinite integral of f dx is nothing but family of antiderivatives of f, right? So if phi is one antiderivative of f, phi x plus c are all other antiderivatives of f, therefore integral of fx dx is nothing but phi x plus c, where this is representing the entire family of antiderivatives of f. In this answer, only this term is a function of x. After that, it's just constants, right? It's only this one function of x which is sitting in the answer of integration of fx dx. Therefore, our aim, in order to compute practical examples integrations also, the aim is only to compute this. The aim is not to compute this entire thing. The entire aim is to compute that one function of x, that one single unique exactly one function of x, which is the antiderivative of f. The moment I have found that, plus c is the answer of my integration, right? So let's begin our very first approach of finding integration of a function in an indefinite manner, right? And as I told you, our entire aim, our entire focus is to find that one single function of x which is an antiderivative of f, okay? That very first technique which helps us find integration of a function, or I should say which helped me get that one single antiderivative of f, is the technique called method of transformation. Now, why am I calling it method of transformation? We all have visited some standard results, some standard integration formulas based upon all those functions whose differentiation we knew, right? The standard differentiation formulas led to some standard integration formulas, right? So, sometimes, or I should say many a times, the integrand, this is the integrand, many a times the integrand is not in the standard form so that I can use my standard integration formulas. So, I transform them. I transform my integrand to the integrand which sits in my standard integration formulas and then use them. Use them to get the answer. It is this reason why this method is called the method of transformation. Okay? How do we transform? What are the ways in which we can transform? And what is the result of transformation? How is it going to reap us the benefits? How are we going to get the exact value of the integral? All these things will be clear by the bunch of examples which we are going to consider under this head. But before I talk about the examples, there is one thing which I want to tell you. This is a very basic important property of integration which I would be in detail doing in the upcoming lectures as well. But right now, to explain you method of transformation, I just want you to keep in mind the statement of this and get ahead with understanding the method of transformation. We will be coming back to it in the upcoming lectures, as I said, and in detail we will be touching this particular statement. This says, what does it say? It says, let integration of fx dx be equal to phi of x plus c. Okay. Suppose f is some function whose integration is given by phi x plus c, where phi x is that one antiderivative of f in terms of x and phi x plus c represents the entire family of antiderivatives of f. Okay. So, let integral of fx dx be equals to phi x plus c then if x is replaced by a linear function of x. When x is replaced by ax plus b, which is a linear function of x, then the integral turns out to be, in its integral, replace x by ax plus b? No, something more. Divide this by differentiation of ax plus b. What is d by dx of ax plus b? D by dx of ax plus b is d by dx of ax plus d by dx of b. D by dx of ax is a times d by dx of x, which is a times 1, that is a, plus d by dx of b, which is 0. So, you get just a as the answer of differentiation of ax plus b with respect to x. So, either divided by d by dx of ax plus b, or I can say divided by a, or I can say divided by coefficient of x in ax plus b. What is coefficient of x in ax plus b? It's a. So either I can say phi of Ax plus b upon d by dx of Ax plus b, or I can say phi of Ax plus b upon coefficient of x in Ax plus b, or I can directly say phi of Ax plus b upon a. So this is the statement which I want you to carefully observe and keep in mind, because in our examples which we are going to consider under this head to understand how we are supposed to transform a function, we will be needing this, requiring this. Okay? So I may not take f of x as my function whom I want to integrate, rather I may take f of ax plus b and then require its integration, which is going to require this particular rule to get to the answer. Okay? That's one thing I wanted to tell you. So now let's begin our method of transformation. Again, before actually starting this method of transformation, again there is a piece of advice, a piece of note, a food for thought for you. What is that? Let me do this question and then I'm going to tell you. Suppose I am asked to find integration of x plus 1 whole square dx. Okay, I am supposed to find this. Now just try to relax a bit, keep calm and look at the integrand carefully. X plus 1 is of the form ax plus b, where a is 1 and b is 1, right? We all know integration of x to the power 2, integration of x to the power 2 is what? X to the power 2 plus 1 upon 2 plus 1, which is x cube by 3, right? So if integration of fx you know, you can calculate integration of ax plus b. Okay? So let me write this as 1. I am saying integration of x square dx is x cube by 3 plus c, right? Therefore, replace this function f of x, which is x square, by f of ax plus b, which is f of 1 times x plus 1. So this is going to become 1 times x plus 1 whole square dx. Its integration is phi of ax plus b. Whatever was phi x, replace x by ax plus b. What you get is, replace x by ax plus b, replace x by x plus 1. X plus 1 whole cube by 3 plus c. Okay? So I just directly used this result to calculate my integral. Let me solve this a bit. A plus b whole cube, a cube, plus 3a square b plus 3ab square plus b cube. Right? Sort this out even. X cube by 3 plus 3x square by 3, which is x square, plus 3x by 3, which is x plus 1 by 3 plus c. That's my answer. Now remember, I am doing this to tell you something, to remind you of something. So have you kept this in mind? Shall I rub that? Well, I would rub it right now, assuming you have kept it in mind very nicely. I will be using it again and again. Now, remember why I started doing this example. I started doing this example to tell you a food for thought, right? Over here you are getting this as the answer. Over here I have written 1 also. Let me write 2 and do something. What do I want to do? I am saying integration of x plus 1 whole square dx. Fine. Over here, you all know x plus 1 whole square, you can expand it. You get a square plus twice of ab plus b square. Integration of the sum is sum of the individual integrals. So you get integration of x square dx plus integration of 2x dx plus integration of 1 dx, which gives you what? Integration of x square is x cube by 3. Integration of 2, x2 comes out. Integration of x is x square by 2. 2 gets cancelled, you get x square. Plus integration of 1 is x and overall plus c. Can you notice something? Over here I was having x cube by 3 plus x square plus x plus 1 by 3 plus c. Over which is given to be as under root 1 plus x square with respect to not x, but this time x square will be what? So question is basically asking you to integrate under root 1 plus x square, but with respect to x square itself. Now if you can understand, because 1 is a constant, therefore this can be written as or rewritten as d of 1 plus x square. Right? D of x square is same as d of 1 plus x square, 1 is mere constant. Now what I do is, if I take 1 plus x square as t, I get integral root t dt, which is something very, very easy, you know. This is nothing but equal to 2 by 3 t to the power 3 by 2. But that's not the answer, because t is being taken as 1 plus x square. So your answer is 2 by 3 1 plus x square to the power 3 by 2, and that is what is the indefinite integral of under root 1 plus x square with respect to x square. So 2 by 3 1 plus x square to the power 3 by 2 plus obviously the constant of integration, and therefore B is the correct answer. The next question says what? It says that if integral e to the power ax cos bx dx is given to be this, then f double dash x will be equal to what? So you are given the information of a certain expression. On the basis of that, you are being asked to compute f double dash x. Now if you can recall from this expression, this is something we have already witnessed, and we know the general scenario which follows for this particular expression. Why? We know that integral e to the power ax cos bx dx is actually equal to, it is given in the question as something else, but it is actually equal to e to the power ax upon a square plus b square, a cos bx plus b sin bx, right? But this has been given equal to e to the power 2x by 29 fx plus constant of integration. Obviously plus c is going to come in both the places. So if you compare both these expressions, what you get is a is 2, clearly a is 2. Also you get that a square plus b square is 29. If a square plus b square is 29, I get 2 square plus b square is 29. So b square is 29 minus 4, that is 25, so b is 5. A is 2, b is 5. Also if you compare, you get fx is a cos bx plus b sin bx. Now if fx is a cos bx plus b sin bx, then what is f dash x? It is minus a b sin bx. Why? Because a constant, d by dx of cos bx is minus sin bx into b. So minus sin bx into b, plus here it will be b square cos bx, right? Again if you differentiate, you get what? Minus ab is already here, square cos bx, and here it will be minus, this is what? B, this was cos bx, so b square, and then here you get b cube sin bx, isn't it? Because d by dx of cos bx is minus sin bx into b, b square is already over here. So from here if you take out minus b square common, you are left with a cos bx plus b sin bx, isn't it? Isn't it? This is minus a b square cos bx minus b cube sin bx, but a cos bx plus b sin bx is equal to fx. So f double dash x has come out to be equal to minus b square fx. But we know that b is equal to 5, so your answer is minus 5 square fx, that is minus 25 fx, and that is what is f double dash x. It has come out to be equal to minus 25 fx or minus b square fx, where b is 5. Clear? Easy enough question. Next we have, if integral fx dx is this, then fx will be what? Okay, so let's see how to tackle this question. Okay. So integral fx dx is given to us as what? Integral fx dx is given to us as twice of fx whole cube plus c. If you differentiate both sides with respect to x, because I want fx, so I don't want this integral sign, I want my fx to get rid of this integral sign. D by dx, when you do, you are just left with fx. This is 2 constant, 3 into fx whole square into f dash x. So over here you get 6 fx whole square into f dash x. Right? This is what you get by chain rule. After this, you can see fx over here, 1 fx gets cancelled, you are left with 6 fx f dash x equals 1. From here, the very situation of obtaining fx starts. You can write this as this is d by dx of fx equals 1, which alternatively can be written as what? 6 fx d of fx equals dx, and now you can integrate both sides. Here with respect to fx and here with respect to x. When you do this, what is it that you get? You get 6. Integration of x dx is x square by 2. So here you get fx square by 2. And this is equal to x. You are left with fx whole square is x by 3. So fx you are having as under root x by 3. That is how you compute your fx when you have the information that integral fx dx is twice of fx whole cube. Now if I move towards the next question, let's see what that calls for. Question is, if this is equal to a log x plus 1 plus b log x minus 2, then what is the relationship between a and b? Now you can see over here, integration by partial fractions is going to come into picture. It is very, very simple. Integral of 1 upon x plus 1 into x minus 2. This will be what? If you put x equals minus 1, I have taught you already in my lectures how to get the values. If you put x equals minus 1, you get 1 upon minus 3. Just ignore this expression, put x equals minus 1. You get 1 upon minus 3 or minus 1 upon 3 times 1 upon x plus 1. That's what you get. Plus, if you put x equals 2, not in this expression, in the rest of the expression, x equals 2 gives you 1 upon 3. So you get 1 upon 3 times 1 upon x minus 2, and you need to integrate this now. Now it's very, very easy. This gives you minus 1 by 3 log of x plus 1 plus 1 by 3 log of x minus 2. And this is exactly equal to the expression a log x plus 1 plus b log x minus 2. And therefore you get that a is minus 1 by 3, b is 1 by 3. So a plus b clearly is coming out to be 1 by 3 plus minus 1 by 3, which is 0. Easy enough question, just using the very partial fraction scenario of integration. If integral fx dx is fx, then what is integral fx square dx? Let's see how to tackle this question. Integral fx dx is fx. If integral fx dx is fx, it clearly means d by dx of fx is fx. D by dx of fx is fx means I can write this as 1 by fx d of fx equals dx. Right? And now I can integrate both sides. This gives me log of fx equals x plus some constant of integration. Log already I have. I'm going to just take for convenience log c as the constant of integration. Now I can write this as fx equals e to the power x plus log c, which is e to the power x into e to the power log c, which is e to the power x into c. Fx is c into e to the power x, so fx whole square will be c square e to the power x whole square, which is this. And when you integrate fx whole square, you actually integrate this, which comes out to be what? C square is constant, integration of e to the power 2x is this upon 2, right? And your answer comes out to be 1 by 2 c square into e to the power 2x, which actually is this. Fx whole square is this, fx whole square c square into e to the power 2x into 1 by 2 is what is the integration, right? So integration of fx whole square dx is what? 1 by 2 fx whole square, right? Just this 1 by 2 is going to come out, rest fx whole square remains the same. Clear? Moving to the next question, we have what is the absolute value of this given integral expression? Okay, so talking about this, you need to first focus upon the values which x can basically acquire in this expression. For this question, I am given that x is going to range from 10 to 19. So x is already given to be greater than equal to 10 and less than equal to 19. Greater than equal to 10 means what? X to the power 8 will be greater than equal to 10 to the power 8. Obviously, if I add 1 to it, again the inequality holds. So this is something that you already have. Now over here you need to find the absolute value of this expression, means you need to find this. What is this? You know that mod of the integral is less than equal to integral of the mod of cos x upon mod of 1 plus x to the power 8. But 1 plus x to the power 8 is already positive, so there is no need to put this mod sign. So this dx. Now if 1 plus x to the power 8 is greater than equal to 10 to the power 8, this implies 1 upon 1 plus x to the power 8 is less than equal to 1 upon 10 to the power 8, which is 10 to the power minus 8. So over here you know that mod of cos x is always less than equal to 1, right? For any x which is coming from any real number, mod of cos x is always less than equal to 1. So this is less than equal to 1, and 1 upon 1 plus x to the power 8 is less than equal to 10 to the power minus 8. So 1 into 10 to the power minus 8, which is this. So obviously this comes out to be equal to what? This comes out to be equal to what? 10 to the power minus 8 into x, where x is ranging from 10 to 19. So that is going to give you 19 minus 10. This is 9 into 10 to the power minus 8, which is clearly less than 10 to the power minus 7. If it is clearly less than 10 to the power minus 7, option number A is the correct one. The only thing to be used over here is the very simple concept that mod of the integral is less than equal to integral of the mod, and that mod of cos x is always less than equal to 1 no matter what real number x is acquiring. Next question says, if fx is a periodic function with period t, then which among the following is the correct statement? Now over here, if you remember the theory part that we've done, directly you will be able to see the answer. Which one is it? It is option number C, isn't it? Why? Because we know that integral a plus nt to b plus nt fx dx is equal to integral a to b fx dx, and this is true for all integers. Over here specifically for n equals 1, the expression is given to you. A plus 1t, b plus 1t. See, a plus 1t, b plus 1t, fx dx is a to b fx dx. So this is obviously right. If you have just the knowledge of basic, very basic properties, which functions which are periodic with period t acquire, very directly you will be able to get the answer.